Good day everyone and welcome to Baymont Cape Projects. I hope that everyone that is attending live is signed in by now. If you can just confirm in the comments section that you can hear us. If there's any problems from our side, we'll try and rectify that as we go along. We ask that everyone please take notes throughout the workshop. We have a Q&A section at the end where Gert will try and answer as many questions as possible. We are here today to talk about transformer oil analysis, which is an indispensable part of transformer maintenance. And if a proactive approach is taken on the condition of the oil, the lifespan of the transformer can be extended. Baymont has been in the trade for 24 years. We operate throughout South Africa and Southern Africa. When it comes to transformer maintenance, we put our full trust in the laboratories to give our customers that proactive approach on transformer maintenance. Today we have Gert Nel from Wearcheck here. He's got 30 years of experience in his field. So Gert works currently between Johannesburg, Durban and Cape Town. So we're very fortunate to have you here, Gert. Welcome and thank you. So Gert, where's your folder? There we go. Okay.
Thank you. Good morning, everyone. I want to thank Baymont Cape for the opportunity as well for Wearcheck to also talk directly to the clients. So I just want to remove my mask, I can't see. It's not every day that the laboratory side can present directly to clients. So it's a unique opportunity for us through Baymont Cape to do a presentation here. I do have a question and answer session at the end. Normally we like to do the questions and answer as we go along, but we have people live streaming in from YouTube as well. And it's going to become a bit problematic if we answer questions in between. So we're going to end up where the questions is. So if there's any questions, please write it down. I will try to answer as many questions as we can. As Celeste has been saying, I've been in this field now for 30 years and approaching retirement age, and it's almost time. Things are changing dramatically in this marketplace, and we will see now as we go along. There's so many things changing now in the transformers, the oils in transformers, the diagnostic on transformers. It's literally not the same than basically 10 years back. Things are changing significantly. Now, the whole presentation, I wanted to shorten the presentation, but this is a presentation which contains a lot of information. So some of the slides we are going to just browse through quickly. It's for time purposes, but the whole presentation is available to the client. So if you're interested in the complete presentation and take your time later on going through it, Celeste have access to the presentation and she can send it to you as well. The first one is just the abbreviations, and here we just maybe have a look at the ones that is more particular to us. DGA, that's where a lot of people are talking about DGA. That's your dissolved gas analysis on transformer oils. Now each of the tests that we are going to look at, each test is discussed later in the presentation. Then we look at your GC, and that's the instrument we measure the test on. And that's your gas chromatograph. And then you look at your different gases that we test for. Hydrogen, methane, acetylene, etc. Yeah, we can maybe PPM, that's one of the important abbreviations. Many of our tests are expressed in PPM, your DGA values, your moisture content. A milligram potassium hydroxide per gram of oil, that's your acid or your TAN as we refer to. PCB, polychlorinated biphenyls. IFT, specific test, interfacial tension. tan. Now a lot of people, if you talk about tan, they think about the tan delta. And it's not tan delta, it's total acid number. So it's two different tests. So just maybe have a look at that. Now, years ago, it was about 5-10 years back, I was in a presentation and the presenter opened with that statement, transformers are killed and not retired. And for a couple of minutes, I wanted to think about what he was saying. And in South Africa, this is particularly true. In the majority of cases, we do have clients that look after the transformers, test them, do maintenance, do preventive maintenance. But it's a small percentage of the transformers in South Africa. Fortunately, we are living in a country where preventive maintenance is not done regularly on the transformers. It's almost in some cases a swear word and money is spent elsewhere. So what is happening, the people are leaving the transformers up to the point where they fail. And the laboratory's work is in 95% of the cases. We can predict any fault developing in a transformer months, literally months prior to that fault actually happening. For that, we need test results. We can't guess it. We need to have a sample, we test, and we make a recommendation to the clients. Now, the next problem for us in South Africa is the load. And I'm talking here about now the normal distribution transformers. Loads are increasing on transformers. You can just drive around in any area and you will suddenly see new informal settlements, new developments. If you go towards Durbanville, like I traveled now the other day around, I can't tell you the roads, but it's huge townhouses that's been developing there. I mean, where there was one house, suddenly they put up 100 townhouses. Not always do they plan for the bigger transformers, and sometimes they use the old transformer to supply these areas. There's people who do plan for new transformers and increase the capacity, but in general not. So our transformers are not just old. If I look back on our distribution, and Wearcheck is looking or testing per year roughly 100,000 transformers that we look after, so it's quite a big percentage of the transformers to make an opinion about. Our transformers is average 30 years old. Our transformer market's old. Now take that transformer which worked at 20-25% of its capacity, that's 30 years old. You increase the load on the transformer to 40-45%. It's like taking a 1967 Volkswagen Beetle and try to drive it to Cape Town from Joburg at 120 kilometers per hour. It's creating problems. So currently our lifespan of the transformers is quite a bit shorter than in the past. And again, the currently 12.5 years is a general statement. So what's the purpose of transformer wells in transformers? Firstly, it needs to insulate the whole transformer, the core. You don't want any flashovers in your core. The second one, it needs to cool the transformer. Now for those, we need to do testing to see if both those areas are still being done by your transformer wells. If any of the test fails, the client must get someone like Baymont Cape out to do maintenance on that well. And the maintenance is to extend the lifespan of your transformer well. Last week I had a discussion with a client. For some reason people think you can do forever and a day maintenance on transformer wells, do purification. And oil is like anything else, it's got a lifespan. Transformer oil's got a long lifespan, but at some point you get to the end of that lifespan where you can't do maintenance anymore. I'm talking about purification. We have to change the oil. Now for that we need different tests, and we're going to discuss this later. But this is the two big properties of transformer oil. It must insulate your transformer and it must cool that transformer. So what will influence the lifespan of the transformer? Firstly, we look at water content. Now, water, for almost anything, we need water in a transformer. So you want to keep the water content as low as possible in your transformer. You want to take it out as soon as you can. The lower the water content, the longer lifespan, not only of your transformer, but of your paper, so forth. Water is not the only thing, but it's one of the most important things in a transformer to keep as low as possible. Shortly in the next few slides, we're going to look at specification, and there's the IEC specification and the ESCOM specification, and some people wants to work on international IEC specification. The problem is the limits. IEC specification is much lower than the ESCOM specification. So it's depending on what you want. It's penny wise pound foolish sometimes to go to another specification just to extend the maintenance of your, that you're not going to do maintenance today, but you're going to do maintenance in a year's time. You're going to save some money, but on the long run it might cost you. So be careful when you want to change specification levels, which we will talk about later. Now the different assets, and that's your TAN that we were talking about, your total asset number. That forms sludge later in your transformer, and that go into your core. It will influence your cooling, it will break down your paper much faster. So asset or TAN is the next one that you want to look at and keep as low as possible to extend the lifespan again, not only of your oil, but of your transformers. And then solid particles. There we look at, there's a few tests, but the general one is dielectric strength, where we measure the dielectric strength of the oil. And any particle in your oil will influence that again. Again, you don't want flashovers in your transformer. Now, corrosive sulfur is a relative new problem that started in transformer oils. It started many years ago in 1999, ABB. At that point, discovered some transformers that just suddenly failed. All the normal tests that we do showed no problem, and then suddenly they've got a failure on the transformers. And at that point, they found it was a batch of oil that was sent into the world with too high sulfur. So it was traced back to a specific batch. But since then, quite a bit of research has been done on this topic. And under certain circumstances, your oil can change from normal to corrosive sulfur content. This is a yearly test. It won't change in 12 months' time. You don't need to monitor it every 3 months. But on a yearly basis, you need to look at your corrosive sulfur content of your transformer oil. If your oil is corrosive to the transformer, you cannot purify. Purification will not do anything to corrosive sulfur. You need to change the oil. Now it's like rust on any metal particle. You can fix that and it will slow it down, but the damage that has been done cannot be fixed. So the sooner you find it and change that oil, the longer your transformer will last. If you don't look after this, you will have a failure later on. But even if you put new oil, virgin oil in, or inhibitors, that process will be now much slower, but any damage that has been done to that point will still happen in the future of your transformer. Now here we look at what we do of your life expectancy, and the first one is care through planned maintenance. Now this involved a few things. There's quite a few points. You should include a comprehensive oil testing program. I do the diagnosis for Wearcheck for all 3 of the branches. Now I do roughly about 150 transformers a day, the diagnosis on that. And I can't make a good informed diagnosis if there's no test result. And the more tests I have, the better trend, the more accurate the diagnosis will be to the client. So everything costs money, and this is one of them. But your transformer is in all probability in most lines the single most expensive equipment on its premises. And for that reason you need to have this. And you need to look at all this, and there's various methods. You can look at an ASTM, Doble, SD Meyers, ABB. There's quite a few methods you can do in your preventive maintenance that you have to look at, and we are looking at most of them. ASTM and IEC is in all probability 95% of all our tests as well as our diagnostics fall in that category, but there's others as well, and we are going to look at some of those in a short while, the type of diagnostics that one can do. Now, this is the two photos there is actual photos of instruments in the laboratory. Now, many years ago, and especially when I started in this field, people were only doing moisture, acid and electric. And again, we're going to talk about this a little bit later more. Now, if you only do those 3 tests, you do save money. Gas adds money to your cost, PCB, furan, every test you do add cost to your test. But if we look at moisture, acid and electric, I can only tell you something about your oil. I cannot tell you what's happening if there's electrical fault in your transformer or your paper condition. So this has been moving over the years to a more full range of tests. We added DGA a couple of years later as a standard test. A few years back, not a few years, about 10 years back, Furanic came. That's your paper condition. In the past, this one is now closed, but in the past, if you wanted to take or know what's the paper condition of that transformer, you had to get someone out to actually take a paper sample. Take a Stanley knife and cut a little piece of paper from your core. And there's not many people I trust with a Stanley knife next to a transformer. So people sat down a little bit and they found that you can actually test the paper condition from your transformer oil. So nowadays, and we will look at that test, the Furanic test, you can test it out of your oil. You don't need to take a paper sample anymore. There is some conditions now to that. Everything's got good points and bad points, and we will look at those. But we can test it now out of your oil. We don't need the actual paper sample to do a test for you. We also get, on a yearly basis, some insurance company contacting me, and then they start looking at the whole history of that transformer. What was done, what was said, what maintenance the client did on those transformers. So even on the insurance side of your transformers, there's some legislation involved. And it's good if you can find out precisely what your insurance is saying. What do you need to do on your transformers? But all of them have got one point across the board, and it's you have to do preventive maintenance. What that means is now open question. If you get someone looking at it daily and write a little sheet up, there's no leaks and so forth, that's preventive maintenance. So it's not clearly defined in many of the cases, but do find out there is insurance legislation around this. And if you look at the transformer lab, in the past you could start transformer labs out of a single garage. You had a couple of instruments and it was good enough to do the testing. Nowadays, our laboratory in Joburg is about the size of this floor area here, a bit bigger than this. Durban is bigger than this, and our Cape Town lab is about half the size. There's now new instruments, different instruments, and every 5 years we need to update our instruments and look after it. The client wants an accurate result. We can only do it with top-of-the-range equipment. So here we are looking at what's the objective of the transformer testing. So firstly, it's to extend the lifespan of your transformer. As I've said, if we do testing, we can, months prior to any fault, we can determine that fault and tell you a fault has occurred. We can't tell you on the 25th of December 2021 your transformer is going to blow, but we can tell you you're heading to a disaster. And I think in the next month this transformer might blow up or stop working. And that can be very risky to some clients if they lose suddenly a transformer. So that's one of the things. We are looking at extending the lifespan of the insulating paper. Now, to do maintenance, you can't do anything about your paper breakdown. That's going to happen, but you can slow it down and you can extend the lifespan of that paper. Because at the end of the day, you can put new oil in your transformer, you can repaint your transformer, re-gasket your transformer, but one thing you can't do anything about is the paper. And this is why we do the testing. And we try to avoid unnecessary breakdowns. If we start developing, in many cases, if a fault is developing in a transformer, even before that fault is that serious, clients like Baymont Cape goes out to the client. Sometimes they can repair the transformer on site, else it's bringing back to their workshop, but they can repair the transformer on a planned shutdown. Now, it's much better to repair a transformer. It's like your car. You take it in for a service, and it's much better to service your car than to wait and drive until it breaks down, because then you might be a head gasket or something very serious. And the same with transformers. Next thing is we are looking to extend the lifespan of your transformer oil. Your oil has got a lifespan, but you can extend that for many years. For example, we've got a Transnet transformer. Unfortunately, only one example of this. It's 1949 manufacturing date. Up to now, no work has been done on that. And every single year, everything still passes on that transformer. Small transformer next to the railways. There's not another example of that I can name to you, but there is at least one of those examples. So it's possible for transformer oils to have a very long lifespan. It's just an exception to the rule. Okay, and then when you get the results back and a diagnostic, it gets sent in many cases to people like Baymont or a third party. They look at it and they will make a recommendation to you. And take note of that. You have spent now money to test it. Act on what was said. We try not to overextend or tell clients to do more maintenance that is needed. When we recommend a recommendation like a purification or oil change, the results are showing us that. So if you want to extend the lifespan of your transformer, paper or oil, please act on that. And the longer that transformer is on, the more money you will make eventually. Maybe not Eskom. Now this is what we are looking at. This 3 circles is what we are looking at. And the small pole transformer on that side, maybe one can look at that. You've got your tank, which is your oil side of the transformer. So looking at your moisture, your acid, your dielectric, the basic test on that. Then we look at any electrical fault that's happening in that transformer. Any electrical fault will generate a specific type of gas. So that's your second circle. We look at a specific gas, and that will tell us if there's an arcing, maybe a sparking or corona problem. And the third thing is the furan, that's the paper in your core. That's the 3 things. Now it's 3 different areas of your transformers, and we need the test results to look at the 3 difference. And if I do an oil test, I can't tell you anything about the paper. Or if I do a paper test, I can't tell you anything about the gases. At the end of the day, there is some overlapping between those 3. But you need to do all 3 to have a clear picture of your transformer. Sampling, I'm just going to browse through sampling where Baymont Cape is doing the sampling, but I just want to make a few comments around sampling. Now, if we get a tender, this morning I had to answer a question concerning a tender. The first questions those tenders always ask you is, what's the certification of the labs? Do you have got SANAS, SABS 9000, 14,000? What's your accreditation? Then they start from the people receiving the sample to the people testing the sample to me diagnosing that sample. What's the qualifications of those people? Are they qualified, or did I get someone from the street in to do the testing of the transformer oils? They never ask or sell them. What about sampling? Who's taking the sample? Now for a laboratory, we have to run standards. Every 10th sample in a laboratory is a standard, traceable back to international standard again. If that sample fails, we have to scrap the previous 10 tests, redo those samples if it fails. So we have got a lot of standards in a lab that we have to run to make sure the results are accurate. But the results are only accurate according to the sample we have received. The laboratory can't even tell that sample is definitely from substation A transformer 2. The label is saying that, but I can't give that promise. We can only promise that the results we gave out is accurate according to the sample. And everything starts with sampling. If this is done incorrectly, nothing that follows will be correct. We will test the incorrect results. The diagnosis will be based on that incorrect results. So please, when you have time, read through sampling and see that this is done. Sampling is such an important part of the whole transformers. Here we are looking at the metal cans. At some point we couldn't get a 1 liter metal can that we recommend. This was the replacement metal cans that's available. A company is started up again for Wearcheck to supply these tins, so we've got again a new supply of tins. But we recommend the metal tin. It seals, your gases can't come out, air can't come in. If it's in a lab and I drop that sample, if it drops on the floor here, the tin will be bent, but we can still do the testing. So we prefer and we recommend sampling containers. I've got a photo and I unfortunately forgot to add it into this presentation. When I was now up in Joburg before I came down to Cape Town, it was in their storeroom. They've got a little shelf with all these special sampling containers that they have received. And if it's got a cap, we have received it. You are wasting your money. If it's not in the correct sampling, we get a lot of, for example, 2 liter Coke bottles. Firstly, your gases is out of those, especially hydrogen. That's the first gas that goes out. So immediately all the gases are out, and depending on the ratio, and the rest is going. Secondly, I've never in 30 years tested a Coke bottle which passed on moisture. We are testing in parts per million. People think if they clean that Coke bottle, it's clean. It's not. That water is absorbed in the plastic. It's there. You can't get it out, and it will fail. So it's going to cost you money. Spend that 30 or 34 rand, buy the correct sampling container, and get the correct results. The one next to it is syringes. Syringes it's got these advantages. Firstly, if you take a sample in a syringe, if I test it today and I close that syringe, we can test twice out of a syringe, and I test the sample in 3 months again, I will get exactly the same values. That's the benefit of a syringe. Disadvantages of a syringe is only 30 or 50 mils. We can't do all the tests. We can only do a DGA. So this is a sampling container, especially for the newer energy sources like your wind farms and your solar farms, where they mainly only look at your gases. Once a year they will test the full range of tests, which they then take a tin. But during the year, when they monitor a transformer for accuracy, they take syringes. You can see also on a picture, is the next one, is your glass that you get. Now, there will always be a discussion if glass bottles are better than tins or tins better than glass bottles. Both are good. If you take a sample in a glass bottle, that's just as good as a tin. The problem with it is seldom you can fill it completely up to the top. So you immediately sit with an air bubble, but that air gap. But that's not the most important thing. The important thing about a glass bottle is it can break. We've got sites that's 300 kilometers out. And now you drive with glass bottles and 2 or 3 of those samples break and you have to go back to that site to sample again. And I myself has broken 2 glass bottles in the years I was still testing in a lab. From a safety viewpoint, we prefer not to do glass bottles. There is unfortunately mines that you have to take glass bottles. If you don't take glass bottles, they open a tin. And the moment they open a tin, everything we test for is influenced. So then we recommend rather use a glass bottle that the security can see there's no diamonds in there for a lab that are trying to bribe, or gold. That's for safety reasons. Then you use a glass bottle. The last bottle there is a small 100 milliliter plastic bottle, and that is for PCB. We only recommend that if a client only wants to test the PCB. If there's not a full range of tests, a lot of environment testing is happening, and a lot of people are only testing for PCBs, then a client can use that bottle. It's a once-off bottle. Any PCB goes into plastic. We have to pay people a lot of money to get rid of that plastic for environment's sake. We cannot do any other test out of it. That's specific for PCB testing. Now we're looking at PCB and the safe handling of PCBs. When you go and take a sample, people, or you have oil, please take precautions. PCB is very nasty. It's been linked to cancers and so forth. Now in South Africa there's not a lot of PCB oil, or they call it arrowchlor oil, left. There's an extremely small percentage left. But what we do have in South Africa is contamination. If you handle transformer oils, handle it as if it's PCB oil. And please use the right equipment for that. Wash your hands afterwards. It's like COVID. Be careful. It's extremely stable component. We can take, it's one of the tests at least in a laboratory, where we've received a sample. That sample can stand for 2 weeks or 3 weeks, and we can still test it again, and we will get more or less the same value. It's an extremely stable component in transformer oils. Now use rubber gloves, not latex gloves. Check the label. Any transformer that has been tested for PCB will have a label. The lab will supply those labels for the client. We are busy at this point. It should be introduced in the next 3-4 months, depending on budget allocations. We've got now a printer that prints on blank vinyl rolls, the PCB sticker. It color codes it according to the Sonos 290 specification. It will change a little bit. The stickers in the past were very glossy. The vinyl is not as glossy as the past stickers, but the lifespan of the sticker is much longer. So it can be in the sun, and the lifespan is quite longer. So we're busy testing that at this moment. That's going to happen. So what if we look at basic test of transformer oils? What are we looking for? And I want to distinguish here between yearly tests and routine tests. Now Wearcheck's got a lot of salespeople working for them, and if you call the salespeople and you want to test your PCB every 2 months and you ask them for a quotation, you're going to get one. Wearcheck will accept your money gladly, but it's a yearly test. Only if you have done work on it, an oil change, then you need to test your PCB again. It's not a test that you need to monitor every 3 months. Furanic is a slow forming. We're looking, and we're going to talk about that in a short while. We're looking at 5 fural components in your transformer oils, but it's slow forming. So you can't monitor furanic on a weekly basis. Even monthly is pushing it. Furanic is a 3-monthly test if you need to monitor the paper condition of your transformer. Now gases is a different story. It shows you any electrical fault in your transformer, and depending on the values, that might be yearly, and we can shorten it to 9, 6 or 3 monthly, and then in extreme cases we go down to either weekly, every 2 weeks or monthly. So that's depending on the tester. Corrosive sulfur, again, I've said it, it's a yearly test. You only need to monitor it once a year to see where's your corrosive sulfur of your oil. You don't need to monitor it any sooner than that. Moisture, acid and dielectric strength. That's also a routine test. You can do it at least yearly, and depending if any work was done on it, you can shorten a time period, but that doesn't need to be monitored every 2-3 months. Apart from maybe a furnace transformer, a different story. Now, if we look at advanced testing, and advanced is a relative principle, because some of this actually should also be done on a yearly basis. Your time delta, or dielectric dissipation factor, and your interfacial tension, it's 2 different tests. But at the end of the day, the diagnostic it will give is the same. The client might get to a point where he has done purification. Let's say your annual sample showed 50 ppm moisture, and you get a maintenance company out to come and purify that oil, and you get it down to 10. But 6 weeks later you test it again and now it's back to 40. If that scenario keeps happening, it's possible that that oil is at the end of its lifespan, and you need to change the oil instead of purifying the oil. And those are the 2 tests that you will do for that. Resistivity is done from your time delta test. The higher the value, the better. DBDS, it's an additional test to corrosive sulfur. There's a bit of a discussion. People say that the DBDS test is more accurate. We also do that in Durban lab. Again, it's a yearly test. You don't test this any sooner than that. And the same with the oxidation stability, flashpoint, viscosity and density. Now, flashpoint, viscosity and density, that I will put in a specialist test category. There should be reasons why you want to do those 3 tests. That shouldn't be even on a yearly basis. There should be a specific reason why you want to do that, maybe some contamination that you're looking for. Here in Cape Town, or a municipality here, at a paraffin problem where people has, I don't know if they stole it, but in their main supply tanks, paraffin was added. And that was added to one of the 20 MVA transformers. So when you get that sort of problem in your transformers, then you need to start looking at these special tests. And this is what we're looking for. We have spoken about it. Your oil condition, those are the 3 tests, the basic tests. Moisture, acid and dielectric. Internal working is your gases, paper, furan. And then your contaminants is your PCB and your corrosive sulfur. Now, moisture. Moisture test is one of the easiest to do. It is also one of the longest running tests that has been standard. Prior to me, at least, I'm not that old yet, but prior to me they did what I call the crackle test, where they put oil on a hot plate and someone was listening for a crackle noise. The problem with that is that crackling, you can only hear it from 100 ppm and higher. And depending on if you work on an ESCOM specification of 15 ppm or the IEC of 30 ppm, both of them is much lower than 100 ppm. So on a crackle test you will pass it, but it can't anymore. Now, moisture is one of the problems that will degrade your insulating a lot faster. Your dielectric strength will be a lot lower. In general, there is exceptions to any rule in transformer. Anything that I say that's a rule, there's always exceptions to that rule as well. Normally you will think there's a relationship between the higher the moisture, the lower dielectric, or vice versa. And yes, in a majority of cases that is true, But it is the exception to the rule where you do get high moisture and your dielectric is also high. But moisture is used in almost every single fault that you'll find in a transformer. Somewhere you will trace it also to moisture. We test it in parts per million. Now this is just a photo of a bigger transformer where you have got a conservator and a breather. And that's the actual instrument where you test the moisture on. It's one of the most simplest tests, fastest tests. This is literally a couple of seconds for a laboratory to test for. You inject it into your reagent there, a 1 milliliter sample, and you get a ppm reading straight out of the instrument. A very fast test, but very, very important for it. Moisture should be done on almost every sample that you do. Now, total acid number. Now, acid is problematic, and acid, one of the things that acid will do over time, and if you look at those vials there, those vials are the colors of the different oils, and there's some pictures a few slides later about that as well. You'll start with virgin oil on a light color, almost a water type color. And over time, that color will change to a very dark brown to almost a blackish color. Now, in general, that is your acid in your transformer oil. That will change your color of your transformer oil. It's impossible to get a low level oil, yellow or white water type color with a high acid. Acid will change the color of the oil. It is, however, possible to get a dark oil with a low value. That is a possible. It's an exception, but it's possible. But you can't get a light color oil with a high acid value. That is not possible. But acid do a lot of damage in your transformer. It eventually forms sludge. And in the days that I was still at ABB, they did some research on this, and I found that after 0.20 of milligram KOH per gram of oil, what's happening, it's becoming exponential, the progress of your acid, and then suddenly it forms sludge, and it almost looks like jelly. And that jelly goes and sits inside the windings of the transformer. So immediately the cooling of the transformer is not as effective as it should be. And secondly, acid is extremely bad for paper, those jelly. So your paper is breaking down a lot faster. And then to get that jelly out of your oil is extremely difficult. That's just the increase of the tan, and like I said, there is exceptions to the rule. At the right side of the picture, the dark oil, you can get a low acid, but on the left side, you can't get a high acid. But this is normally the progress. As the acid increase in transformer oil, the color will change of your transformer oils. We are busy standardizing on this color chart. We are using this already in our WSL, that's our Johannesburg laboratory. That's also our SANAS accredited laboratory. There we've got a specific instrument that gives out the value, AST method. Our two laboratories in Durban and Cape Town is still using the visual, where we will say it's a straw, light straw, amber type color. But this is the standard that we're working towards on all the laboratories, that you get a color code, and then you also are not reliant on a person. For me, an amber, and the next person, an amber color might be different. So it's just better to standardize on a number, although it's difficult now for some clients. They see a number, let's say 2. What color is 2 if they don't have the chart? So there's some advantages and disadvantages to it as well. Now the dielectric strength is the third and the last test of the basic test of transformer oils. And this is the insulating part of your transformer. This is what we test here, is how good your transformer oil is still insulating. And in the dielectric strength, what we are looking for is the flashover, and I will show you now how that's done. Your winding in your transformer is 2.5 millimeters apart. So we test in South Africa at least. The gap in our instruments is 2.5 millimeters apart. And there's certain limits. Again, Eskom were looking at limits 60 kV and 50 kV. IEC were looking at 40 and 30 kV. So depending on which standard you're using. But this is to test the insulating part. And normally the higher the moisture is, the lower the dielectric will be. But there's also exceptions to that rule. There can be particles in your oil, either dust particles or even small paper particles, which is not always visible with the eye, that can influence your dielectric strength. But if this is too low, you can have a flashover in your transformer. So this is also to extend the lifespan of your oil, but as well as of your transformer. And the next two pictures will show you how this is done. This is the test where we use also the most oil. That is why we standardized on a 1 liter tin. The vessel there takes 400 milliliters of oil alone, and you still need to clean that vessel. Next one is a bit clearer on your spheres that you've got in your vessel. And that electrodes is cone shaped as well and not flat. Now there's a lot of methods out there. One of the methods that Anglo was looking at was a flat type electrode with a 1 milliliter gap, and unfortunately we couldn't meet that because it's not done in South Africa. This is the standard in South Africa. This is how the instruments are supplied for. And that's a bit of a clearer picture of the electrode that we are looking at. So what's happening, and this instrument is basically just a transformer. You increase the volt on the one side, and all of our instruments can go up to 100 kV. So we increase the voltage on the one side, and we measure how much voltage it takes to flash over between those two spheres. It's quite neat to see, unhealthy to touch. The next slides, this slide we are looking at, is the different specifications, and here we are looking at IEC specification, Eskom specification, and depending on what a client wants. In the past we only could diagnose into the Eskom specification, our new online software. We can now set the specification. We have an Anglo specification as well. Anglo's got their own specification they've written. So all their transformers is diagnosed completely on a different specification than this. But this is the specification that you can look at. This is the general one, and one should be careful not to change specification too fast, just to be penny wise. Now gases, this is quite interesting. We are looking at 10 different gases that we analyzed for, and each specific electrical fault in a transformer will generate a specific type of gas. We start with hydrogen. Sorry. We start with hydrogen, which your fault in your transformer at that point will be around 150 degrees Celsius. We end up with acetylene, which will have roughly 1,300 degrees Celsius. So each gas will be generated at a different temperature in your transformer. And each gas will tell us something, and we're looking at if there's any overheating in your transformer. Loose connections, we can pick that out. Even a breakdown in your cellulose, we looked there at ratios, but unfortunately if this was so easy to do just with the gas, we wouldn't have needed a furanic test or actual DP test on your transformer. Arcing, which is in the most serious gas you can get, and I don't want to say only look out for this gas. If that's, then you need to switch off. All of them is important, but that's the one gas you don't want to see. At that point, the fault in your transformer is quite big. Partial discharges, which you will find between your hydrogen and your methane type gases, and then sparking, which is in most cases your methane gas. This is what every gas will show you. Hydrogen will show you coronal, and in serious cases arcing. I want to go down to the ethane ethylene gases, which is your overheating. This is the two problematic gases. All your other gases, hydrogen, methane, and acetylene, the type of fault that's in your transformer will show you some mark in the transformer. And people like Baymont Cape will be able to see it on site. Those two gases, which is overheating, unfortunately doesn't leave any marks. So that's also the slowest type faults. It's normally slow forming. It's the slow death of your transformers when you start having your overheating. Your arcing, your sparking type problems, it's relative fast type faults which will happen, but overheating is normally over a long period of time. Very slow death for the poor transformer. The photos here, the first one there on top there is arcing, and I don't know if any one of you have ever welded, normal welding. Now that arc between your electrode and piece of metal, what you were welding, that arc is precisely what I'm talking about in acetylene. If we are talking about arcing in a transformer, that's happening in your transformer. And that's the one thing that you don't like, because that will eat through any metal. That's your first picture on your left-hand side. The second picture and the third one there at the bottom, the left one on the bottom, that's with infrared camera that will show you overheating type problems. And one at the bottom is overheating, the cooling fins was blocked on this transformer. And the people came out with an excellent infrared camera, and on the places where it's so red, that's where the blockage were. So it saves time on maintenance as well, as you now can see visually where your maintenance should happen on your cooling fins. And the last one there at the bottom on the right hand side, that's your sparking type problems. That's when you normally have loose connections. That's the sort of thing that will happen in your transformer, and that's when we will start seeing methane in your transformer. Now this is where the instrument, where all happens. On the left hand side is the instrument itself, the DGA, gas chromatograph. The right hand side, that's your autosampler. Now we've got two of these specific ones in Joburg that can take 40 samples per run. The bigger one that we have bought now for them, it's 120 samples per run. Each sample takes 30 minutes to do. On the right hand side, this is now where the preparation happens for your sample. Now you take from a 1,000 liter smallish transformer, you take a 1 liter tin. That you brings down to this little vial there on the right hand side, which is a 100 milliliter vial. So you take that whole transformer, comes down to that little piece there where we have to test from. That's the vial where we test the oil. We are talking about headspace. If you look at that vial, half of that vial is full of oil, the other half is headspace. Now what that instrument is doing, it's shaking it, heating it up in the process prior to its testing, and all your gases in your oil goes out of the oil into that top part of the vial, and the instrument then analyzes that headspace of the transformer oil. Very accurate method if everything was done correctly. Left hand side, unfortunately you can't see that clearly, but that's where all your vials are put in when they are empty, and the whole preparation, it can take 20 of those vials, so 20 samples at a time can be prepared for a DGA test. I've left this in. We used on our online program a slightly different values for the DGA. I've left the newer IEC in. DGA is difficult. There's about 20 different IEC, ASTM methods out there that you can use with limits on it, or CSIS guidelines. But this is only important for your first sample. This is your alarm. Gases, and a lot of the mines, they require a specific value on DGA. They want to know if your DGA hydrogen gets to 200, they want to take the transformer out of service. It doesn't work like that in gases. These values are just valid for the first test. Just to tell you, something is starting to happen in your transformer. It doesn't matter what that value is. It can be almost anything. What is important of gases is how much gas is generated by a transformer per day. Most of the transformers are generating gas, and you even get oils that have a tendency to generate gas. That's normal in a transformer. What we want to know is how fast that is happening. So when you get down to the diagnosis, you look at trends of transformers and you look at the whole history. And it's quite important now to look at the industry that transformer is in eventually. You will find that shopping malls, for example, all of them got the same sort of problems. Casinos, same thing. All your casinos will have the same sort of problems. I don't know why, but it's happening. Transnet transformers, they've got the electrical locos. Them and the wind farm transformers got the same sort of issues. So it depending on the industry as well. So it's not just values that you need to look at. And for a distribution transformer, if that contains 5,000 ppm hydrogen, that's a problem. And someone needs to go and stand quite a distance already and take photos. If it's a wind farm transformer at 5,000 ppm, that's a relative normal for a wind farm transformer. And the same with a furnace transformer. So the type of transformer also play a role. So there's no specific values. It doesn't work. This is just your lamp to start showing you where you need to start looking at your gases. And irrespective of which one you want to start looking at. Now this is two photos. On the left hand side, that's a core that have blown, a transformer that have blown. And a core is not that round anymore, and it should be round. So this transformer is not working. And both of these photos were taken at a LH Martinezson manufacturing plant in Joburg. They've got a beautiful manufacturing facility there as well. And this was taken there. And on the right hand side, they were busy winding a new core. Now we are going to talk about furans. Now furanic, we are testing now for the fural components in the oil. And the paper in a transformer is just like the normal paper that's there on the tables. If you think about logical, what will damage that paper on the table? That will damage your paper in a transformer. Paper in a transformer is just a better paper, but the same things still apply. Water. If you spill water on it, it will damage your paper. Acid, oxygen, oil oxidation, and then most importantly, heat. That's the next thing that will damage your paper. So the hotter the transformer is running, the faster the paper will break down. Now, your paper, over time, and this is a slow forming, again, this is not happening overnight. The paper should last 45 years, so over 45 years it will break down. It's quite a long time, but in that 45 years, paper generates CO and CO2 gases. So the ratio that we are looking in a transformer for CO and CO2 can also come from the paper. And in the past, those ratios were recommended for when an actual DP test should be done. Now we can do a furanic test, but that's where the CO and CO2 ratio comes from, that's two gases your paper generates. The next gas is hydrogen. Now, hydrogen, and you combine that with oxygen in your transformer, you set with water. So if there's an increase in your water and no one can explain that, one should start looking at your paper eventually as well. It could come from your paper. Again, paper is not going to generate 40 ppm in a month's time. It's slow forming. And that is the 5 fural components that we test for. The more we find these components, the lower the value. So it works, it's not like gases. If we find a high value of gas, that's not what we want in gases. We don't want to see on our gas chromatograph a peak of hydrogen of 1000 ppm. That's very bad for a transformer. On furan, it works the other way around because we are working in predicted DP. The more we find, the better value. So we want to see of this as little as possible. Unfortunately, there's a few things that influence this test. If you have done purification on it, this is a chemical component in your oil that we are testing for. So purification removes quite a few of those, not all, but suddenly where your furan, the predicted DP will be 300-400, after purification you will see readings of 600-700. So if you didn't know purification was done, the value will seem normal. If you have done an oil change on your transformer, all the furans are gone. It's gone with the old oil. And we have to start from scratch, but then we start looking at trending. We need a first sample to have a baseline, and then we trend the furan, how fast that furan is now falling in your transformer. And there's limits to that. Now for furan, the transformer must be energized. So if you have got a transformer that's standing in the storeroom, it's not worthwhile to test your furan. If the transformer is less than 5 years old, it's not recommended to do a furan. It will be good for a baseline, but you won't see paper problems in the first 5 years. There must be exceptional problems with your transformer if your paper starts breaking down in the first 5 years of the lifespan. Then if it's a correct sampling container, we have found that if you use plastic bottles, which some clients do, the plastic draws the furanic components to the side of the transformer of the plastic bottle, to the side of that oil. So immediately if the lab tests it, they get a much better reading than the actual furans. So sampling containers in the case of furan is quite important. It's a relative time-sensitive test. So from where you take the sample and up to the point where the lab tests it, it should be as fast as possible. If the lab also gets a sample where there is a furanic, the first test they have to do is moisture, gas, furan. That's a free test they immediately have to do the moment they open that sample. Then they start doing the dielectric and TAN and the rest and PCB. But those three are the time sensitive. Because oil is hygroscopic, it absorbs moisture. Your furan is not a very stable component in your oil. The moment we open that tin in the laboratory, the test must be done as soon as possible. Now that is these instruments actually look quite nice. For anyone that's in gaming computers, RGB lighting, these instruments are like that. It looks quite neat. It's just blue lights. Everyone is very impressed with it. What is not very clear is on a very top part of that, just under those bottles, that's where the autosampler is for a furanic instrument. This instrument can take 80 samples, also half an hour per test for a sample. In this test, preparation in a lab are key. If the laboratory, if the technician has an off day or taking too fast, it can directly influence this test as well. So even in a lab, faults can occur with this test. We're testing down to parts per billion, which is 1,000 times lower than ppm for moisture. So a lot of things can go wrong with this test. It's such an important test to have your calibration of your instrument correctly, the preparation, and the sampling time between sampling. Now those are the values that we're looking for, and like I said previously, for this test, on the test report, you're looking as high as possible value. You want a value higher than 600, then it's normal. Now there's a couple of categories, and eventually a critical point is 200. Furanics in this case is a lot like gases. This is your limits. But when you get to your critical point, it doesn't mean your transformer is going to blow immediately. There's still a lifespan left in your transformer at that point. But at that point, you shouldn't do any filtration or oil changes on your transformer. It means your transformer is critical. You need to monitor it now on a free monthly basis at least, and you have to replace that transformer as soon as possible. At that point, we start looking at your gases. We've got one client, because of budget constraints, can't replace his transformer now. His furans are running at levels of 70. But what we are looking at that now, he's monitoring that on a monthly basis. We're looking now at your DGA. Because as long as your DGA, there's no DGA in your transformer yet, it still shows you that paper is still okay in your transformer and can still last. The moment you start seeing now DGA, any increases in your DGA, it means you need to switch off and replace that transformer immediately. So this is now where that three little circles cross over to each other, is at that point. But under 200, when you do then purification on your oil, you actually get the opposite. Prior to this point, you want to extend the lifespan of your transformer. You want to extend the lifespan of your paper. If you start doing any maintenance work under 200, you get the opposite. The little bit of lifespan that's left in the transformer, you're now making shorter. So under 200, you need to look after your transformer at that point. No load changes, no sudden switch off. Okay, polychlorinated biphenyls. The first few photos, just a few explanations on this. If you have PCB oil and you have to get rid of it, you can either put it in little drums and they send it off to some third world to put it deep in a mine. Or you have a dechlorination plant, that's on the right, and unfortunately there's just one in South Africa. Enviro Oil in Alberton's got one. That is the best option to take. We were looking at bringing in one at one point, and that was still when the rand-dollar exchange rate was R6.50, I think. At that point, this plant was 14 million to bring into South Africa. Now I think it's about 6 times that price, and there's a lot of legislation around PCBs. If you start looking at that side of the business, it's just not worthwhile to bring this plant in. But with that plant, you save 90% of your oil. The first option where you put it in drums, that's taken away and you lose all your oil. With a dechlorination plant, you lose about 10% to sludge of your oil, but the rest you get back at 0 ppm PCB. The last photo there is company in Midrand, Modderfontein, sorry. They burn the oil. There's a zero outlet to the air. It's special ovens, very expensive, but in both these cases you lose all your oil. Now this is the PCB instrument. We have to have special licenses to operate this. In Durban as well as Joburg, we've got 2 of these instruments, and here in Cape Town we've got 1 instrument. Difficult test to do, difficult test to interpret. Where you will have one peak for hydrogen, for example, or acetylene, which is easy to integrate. We are looking at 3 aerochlors when we test PCB. Aerochlor 1242, 1254 and 1260. That was the names when PCB oil was sold. Now we refer to it just as PCB, polychlorinated biphenyls, but it contains 3 different aerochlors that we are test form. But each aerochlor you're looking at about 50 different peaks, which makes up your sample. Then that can be influenced by the prep. It can be influenced by some chemicals. It's an extremely difficult test, not just in South Africa, worldwide, to interpret and to interpret accurately. If you have tested the PCB at ppm 5, 5 is still okay, but if we look at higher levels like, let's say 120, and you test that PCB again, you're not going to get 120 again. It's quite a difficult test to do accurately. but very important. South Africa was a signatory on a Stockholm Convention, which stated that by 2023, all oils in South Africa must be at a PCB level of 0. And I think some people forgot about that. That's not going to happen, and we don't have the money in South Africa even to do that at this point. So I think we will, at the end of the day, we will settle at less than 10 ppm maybe, depending on all these people decide on, but we're not going to end up with 0 ppm PCB in all the transformers. That's just something that's out. Now, years ago, there were only basically a category less than 50 and above 50 and above 500. SANS 290 SABS has decided no, that doesn't work. We need to put it in different categories. So you've got now 5 categories for your PCB oil. The changing of the oil is still, if the oil is above 50 ppm, then you need to do something about it. If it's below 50, it's still okay. So now we just have different stickers and someone making money out of the printing of the stickers. That's just an example of the different colors of the stickers that needs to be on your transformer. And here we are going to talk now on the corrosive sulfur. And the little picture there is the standard that the lab is using. When we test in a lab for corrosive sulfur, the little copper strips, and that's a 3-day test. So it takes us 72 hours. You can't send in a sample this morning and demand results this afternoon. It's 3 days. We need to, there's certain conditions we need to do. We are trying to, in that 3 days, to do what a transformer is doing. We test it with paper, and that's the color code that we are measuring it against. And again, if you have this, you either need to change the oil or put inhibitors in your oil. The moment you start putting inhibitors in your oil, your cost of ownership is increasing. You need to test the inhibitor content on a yearly basis and add that. But corrosive sulfur can cause quite a bit of damage in your transformer. Both those pictures are taken from actual transformers. This is what's happening if your oil is corrosive to your copper. And on the right hand side is a transformer that completely failed. All the other tests were normal. Furan, gases, oil, all of those were normal. And the transformer just blew. And that's the cause of it, is corrosive sulfur. So please do at least on a yearly basis the corrosive sulfur test. That's just the classification that we work on. Up to 2, it's still normal, but anything from 3 onwards, you need to do something. If it's 4, you definitely need to do something. The tan delta, the instrument and the dielectric instrument looks very similar. And we test this as, the instrument is testing this as 2 different temperatures. And tan delta is, tan delta at the end of the day it tests for the leakage current through your oil. And there's quite a couple of technical aspects to that. But the answer to when you test the tan delta, what will be recommended to the client, if this test is too high, you need to change the oil or do on-site regeneration. This is why we do a tan delta test. This is just a yearly test. You don't need to do this on a 3-monthly basis. Resistivity is one of the tests being done out of a tan delta. The instrument tests for that, so you get the reading. In the past, we have charged for both tests, and we have discontinued that as well. Because if we test the tan delta, we do get a resistivity result as well. And it was a bit unfair to charge the clients for both, so we have dropped that and only charge the clients now. In the case of resistivity, again, the higher the value, the better. Tan delta, the lower the value, the better. The inhibitor content, we currently only have 1 lab. Not many clients is testing the inhibitor content. Up to a couple of years ago, all the oil in South Africa was basically uninhibited oil. slowly but surely inhibited oil has been coming into the marketplace. And when you start looking at things like corrosive sulfur, where you need to add inhibitors to your oil, even if you have uninhibited oil, suddenly the inhibitor content becomes important. And like any additive, if it's in your motor car or in a transformer, additives, the value decreases over time. So you have to test this to get a value. And if this is not within specification, you can see there the specification is 0.3 to 0.4%. You need to add inhibitors again. So the moment you start playing around with inhibitors, the cost of ownership has increased for the client. Now this is the different interpretations that you can do or use in the diagnosis of gases. And we don't, in South Africa and Wearcheck, we don't use everything, but there's quite a few more that you can do. I've been working with ABB in Sweden a few years back. They've got such a nice program. It's such a copyrighted program that it only stays in Sweden in one specific office block. So you send all your information to them, they type it in, and they send you a report back. That program is not shared with anyone. But if you do everything that program is asking, that's electrical test, not just the test that I was talking about today, electrical test and quite a few others as well. If you do everything, they can almost tell you up to the day that transformer will pack up. But that program is highly secret with ABB in Sweden. In South Africa, we use the Doornberg, Rogers ratio, the IC 60599, DeWalt triangle, and pentagon. Now, that is mainly nowadays used. All the other methods is older. The newer diagnostic methods is nowadays the DeWalt triangle and pentagon, both of which is now into the Wearcheck software. We look at key gas, CSIS guidelines, Westinghouse, and then the concentration, the combustible concentration limits. I look at it, but it's like smelling the oil and guessing the acid. It's there to use, but it's just a guideline. What we don't use is the next four, is the Doble, IEE, Hydro-Quebec Canada, BBC Switzerland, and EDF. Those are available, we just don't use it in South Africa. So there's quite a few methods you can use in the interpretation. Now, the only thing I want to talk about on this is again the limits for DGA. It has been shown previously, and what type of fault each gas do, and the production rates. But what is interesting of this slide is in the middle, you'll see the solubility of transformer oils. Now you see hydrogen is the least soluble, that's 7%. And that means it will go as fast as possible out of your transformer oil. And acetylene, which is the baddie of all of them, that's 400% soluble in transformer oil. And the solubility of the transformer oils, that is why we can test gas. It gets absorbed in the oil, and we in the laboratory can test for that. Now people say, but I've got a buchel strip or buchels on my transformer, so why do I need a gas test? Now in the case of that 7%, to convert that to parts per million, that's 70,000 ppm hydrogen, which means transformer oil can absorb 70,000 ppm hydrogen before it will make an air bubble to trip the buchels. So if it's a slow forming fault in your transformer, the oil will continue to absorb that gas. If it's a fast forming fault in your transformer, that will then blow your buchels. But 70,000 ppm hydrogen, you don't need to stand far, you need to be in a helicopter to take that photos at that point. So this is why it's so important to do DJ. Everything we test for is combustible gases. And the lowest of them is hydrogen solubility wise at 70,000 ppm. Acetylene is 400,000 ppm. And I've never seen those values, not even in a tap changer. Rogers ratio, I don't want to talk, this is one of the oldest methods that was available. When I started in this field, it was already old. So this is very old, but it's a good method. And the problem with the Rogers ratio is there must be a fault. And if you take a normal, where all the gases pass, and you take the Rogers ratio and you try to show a fault, you will find a fault, even in a normal transformer. So your gases must be at a specific level before you start using the Rogers ratio. But it's a nice method, it's quite an accurate method. And what's also nice about it, it shows you more or less the type of fault that's in a transformer. So it's not obsolete, but it is some newer, more accurate methods which we will have a look at now. Now this is the Duval's triangle. I haven't put a pentagon in here. This is where it all started with the newer diagnostic methods, is on the Duval's triangle. Extremely accurate method to use. And the Duval's pentagon, especially if you take the stage 2 into consideration, it is incredibly accurate. This is the newer methods to use. But in gases, you just don't look at one method. Even if the Duval's triangle or pentagon gives you a fault type, you need to look at the other methods as well. But diagnostic-wise, this is one of the newer and better methods to use. And for the last few slides, I'm almost done. We're just going to quickly look at alternative fluids. When I started in this field 30 kilograms back, there was only mineral oils and uninhibited mineral oils and specific limits for gases. It was very easy to diagnose. Nowadays, we are looking at uninhibited, inhibited, and in most of the cases, the client itself doesn't know what oil he's got. So he can't tell me what I must diagnose again. So becoming difficult, more and more difficult. What's taking over, especially in South Africa, is the newer oils that's now coming into the marketplace. Now, on mineral oil, we sit already with the IEC specification, the ESCOM specification, and the Anglo specification. So that's already interesting to diagnose mineral oils nowadays. Now we get to the silicons and the ester oils. Totally different type of oil. Own specification. I've got one client in Port Elizabeth. He's got 6 transformers. 2 of each oil is in these transformers. So he's got 3 different oils in that 6 transformers. So now I have to diagnose it correctly. The guy taking a sample has to done it correctly. The guy going to do the repair work needs to know what oil is in there. It's becoming interesting. And well, there's reasons why this, and we will now look at your silicone oils firstly, why people do this. But this is part of our living now. Greenpeace, biodegradable, that's all words people like to hear nowadays. So ester oils is becoming a huge thing in South Africa. That's biodegradable. So silicone oils. Safety, it's the same with ester oils. It's higher flash and fire points. Oxidation stability is much higher. It's not biodegradable. And cooling is much better. The worse. Silicone oil at least is relatively easy to see on site. If you take normal virgin oil, you take silicone oil and you add it together, the 2 oils don't mix at all. You immediately see that on site. So this is very easy to see if you've got silicone oil and mineral oil. Problematic is the next one, is ester oils. That and mineral oil mixes. So if those 2 have been mixed, it's virtually impossible, not quite, but it's nearly impossible to tell in what ratio that has been mixed. But this is taking over in South Africa. Transnet, almost every single transformer they order now, including electrical trains, now contains this. Eskom is busy with a huge program to replace their oils with ester oils, as well as Anglo. But you do get two different types of ester oils. You get a natural ester oil and a synthetic ester oils with vastly different specifications. And again, every single one that we have received, I phoned the client and I asked them, what type of ester oil do you have? You're supposed to have this ester oil in it, but I'm not sure. And not a single one so far can answer me. They put the ester oils in, but no one knows what type of ester oils has been put in. One is made specifically for a sealed unit, and one is made for a transformer that's open. And you need to know both. And it's extremely good. Your flash point, especially in mines where there's a fire risk for the people and people working underground, this is a big plus for them. Higher flash point is significantly higher. It's biodegradable and slower aging of your insulating. It oxidizes in air, so you must have your synthetic ester oils. And if you retrofill a transformer which had mineral oil in it, the viscosity of ester oils is significantly higher than mineral oil. Immediately the cooling of that transformer is not as good as the cooling of mineral oil. So immediately you start seeing an increase in your ethane and ethylene gases as well. A new transformer designed for ester oil, you don't have that problem. This problem is mainly when you start retrofilling transformers. Now this is the end now. Thank you for listening. So yeah, now it's the time if you've got questions.